Let's look at section 2.4, which is just more on slopes. So slope and parallel lines. If two non-vertical lines are parallel, then they have the same slope. If two distinct non-vertical lines have the same slope, then they are parallel. Two distinct vertical lines, both with undefined slopes, are parallel. So remember, parallel means they will never touch. So let's kind of draw an example of that. So these are parallel and their slopes are the same. So both of these if-then statements are saying parallel lines have the same slope. Lines that have the same slope are parallel. Then it says two distinct vertical lines. So think about two vertical lines. They both have undefined slopes. And they are parallel to each other. Example 1, writing equations of a line parallel to a given line. Write the equation of a line passing through this point and is parallel to a line whose equation is y equals 3x plus 1. Express the equation in point-slope form and slope-intercept form. So let's look at what the slope is of this. It's 3. So we have a slope and we have a point. So m equals 3 and negative 2, 5 is our coordinate pair, our x1, y1. That is all we need from this equation. Now we don't care about it. We only want the slope because we know that the lines have to be parallel. So now we are going to use the point slope form. That's the y minus y1 equals m x minus x1. So we're going to plug in what we know. We know that m is 3. The x is just x minus x1 is a negative 2. And then it's y minus y1 is 5. So we need to simplify and write it as slope-intercept form. Slope-intercept form is y equals mx plus b. So we need to distribute first. I have a minus and negative, so I'm going to go ahead and change that to a plus. So it's y minus 5 equals 3 times x is 3x. 3 times 2 is 6, and this is positive. The minus 5, I'm going to add 5 to both sides. And we get y equals 3x plus 6 plus 5 is 11. This is the equation of the line that we've been asked to find. It's parallel to this one because they have the exact same slope, and it goes through this point. And a way that you can check your work is we can put in the equation. Let me clear out what I have. I can put in the 3x plus 11. And I'm going to go to the table of values and make sure that negative 2, 5 is a coordinate, which it is. And we know they're parallel because they have the same slope. But I'm going to go ahead and put it in anyway. So 3x plus 1. Now hit graph. And you can see that they are parallel. Slopes and parallel perpendicular lines. So perpendicular means that they cross at a right angle. Another way it might look is, let's see, we have this. If I do a line like that, so this is a right angle as well. So see how this one's a positive slope and this is a negative slope? So the way that you can find your slope is you are going to do the opposite reciprocal. Opposite means change sign. So if it's a positive, the perpendicular would be a negative. Reciprocal means flip the fraction. So if I have 1 slope is 3/5. Then a perpendicular slope would be, this is positive, so it'd be negative, and then flip the fraction 5/3. So if two non-vertical lines are perpendicular, then the product of their slopes is -1. That means if I multiply them, I should get -1. So whenever you multiply 3 times a -5 is -15. 5 times 3 is +15. That equals -1. So that is the rule with perpendicular numbers. Opposite reciprocal. If you multiply them, you'll get a -1. Horizontal line having a 0 slope, like this one that we drew, and an undefined slope, like this one, they are perpendicular to each other. Okay, keep on going. Example 2a, writing equations of a line perpendicular to a given line. So we want to write the equation that's perpendicular to this one. Well, in order to know the slope, I need to rewrite in y equals mx plus b form first. That way I can find what my slope is. So I need to rearrange it. I'm going to draw my line down my equal sign. I need y to be over here by itself, so I'm going to subtract the x. 3y minus 12 equals -x. Then I'm going to add 12. 3y equals -x plus 12. Divide by 3 all the way through. So y equals, when there's not a number right here, we can go ahead and put a 1. So this is a -1/3 x. So the slope is -1/3. 12 divided by 3 is 4. So our slope of this is -1/3. So you can't see that. So it's -1/3. So then the perpendicular slope is you flip it and change the sign. So this one's negative, so it'll be a +3/1, or just 3. And that's what it's asking. Find the slope of any line that's perpendicular to that. So my perpendicular slope is 3. Okay, now we are going to write the equation of the line that goes through this point perpendicular to this. We've already found the slope of this. So the perpendicular slope is 3. This is the one we are going to use. Now that we know the slope of our original, we flipped and changed the sign. We don't care about that anymore. We care about this, and we care about this. That's what we are going to use. So x1, y1. It says express the equation in general form. So let's look at how we would write this first. The easiest way is y minus y1 equals mx minus x1. Let's go ahead and plug it in. So y minus a -6 equals 3, x minus a -2. So we're going to add those, change that. So we get y plus 6 equals, distribute, 3x plus 6. Subtract 6 on both sides. Well, they cancel. So it's just y equals 3x. They do want us to write it in general form. So general form is like ax plus by plus c equals 0. So if I have y equals 3x, what I could do is I could move it over here. And I get 0 equals 3x minus y. And then just flip them around. 3x minus y equals 0. We don't have a constant because the constant's canceled out. So this would be our general form. All right, let's look at slope as a rate of change. Slope is defined as the ratio of change in y to the corresponding change in x. It describes how fast y is changing with respect to x. For a linear function, slope may be interpreted as the rate of the change of the dependent variable per unit change in the independent. So it'd be like change of the dependent over change of the independent. So an example of this would be miles per hour. We would do change of miles over change in hours. And that's how you get the MPH, miles per hour. Because you go for so many hours, that's independent. You can drive for as long as you want or as little as you want. What's dependent is miles. How far you go depends on how many hours you're driving. Example 3, slope as a rate of change. In 2000, 11.9 million young adults lived with their parents. In 2017, 22 million young adults lived with their parents. Use this information to find the slope of the linear function describing young adults living with their parents. Express the slope correct to 2 decimal places and describe what it represents. So let's think about it as our independent would be years or year. Our dependent is going to be how many young adults live with their parents, so number of young adults living with parents. So independent, just like this. Remember we wrote it when we first started talking about slope. We did change of y over change in x, because y is your dependent, x is your independent variable. So this would be year would be x, dependent would be y. So if I write it as ordered pairs, I would do like 2011.9 mil. And then the other would be 217, 22 million. So my rate of change would be represented by doing change in, what's the dependent? Dependent's your y. Change in number of young adults. I'm not going to write it all out again. Over change in years. And we actually have a space on the next slide where we're actually going to find the rate of change. So we have these ordered pairs. Yeah. So we would just plug in the change in young adults over change in years. So let's do be 22 million minus 11.9. Remember, this is million people. And then this is how many years. So it'd be 217 minus 2000. So when you subtract, you get 10.1 for 17 years. So 10.1 million in 17 years. That seems like a lot. 10.1 divided. Oh, I forgot to put the decimal. So our change, I'm going to just go to 2 decimal places, 0.59 million per year. So let's think about that. It's less than a million, so it's actually young adult per year. YA. So it's not even It's a little over 500,000, so it'd look like that if you were to write it out. All right, let's look at average rate of change. So let's say we have a polynomial that has this curve going on here. Then we need to find the average rate of change. So we find 2 points and we go through them, and we're going to find the slope from those 2 points. So remember, f of x is the same thing as writing y. So if I'm saying f of x1, that means this coordinate. x1 is some number, and then f of x1 is that coordinate right there. x2 and then f of x2. So don't get confused whenever you see f of x. It just means function of x. So it says find the average rate of change for f of x equals x cubed from x1 is -2 to x2 is 0. So what we need to do is let's do our x and f of x or y, so we have 2 values. So our x1 is going to be -2 and our x2 is 0. They've given us the function. So what we'd do is f of -2 would be found by doing -2 to the third power. And when you do that, it comes out to be -8. And then, so that means that we have the coordinate -2, -8. This is x1, y1, or I could have said f of x1. They're the same thing. So then if I do f of x2, so f of 0 equals 0 raised to the third power. Well, that's 0. So now we have 0, 0. It's our other coordinate. So we're asked to find the slope from these 2 points. So that would be just like this. Let's see, this is y1, this is x1, this is x2, sorry, y2, or f of x2. F of x2 is the same thing as saying y2, so it's still the same formula, y2 minus y1. So slope would be found by doing 0 minus a -8 over 0 minus a -2. Minus negative becomes plus, minus negative. So that's 8 over 2. 8 over 2 is 4. So our slope is 4. 4 over 1. So an application of this would be where you actually have a graph and you want to find your average rate of change just for one particular segment of data. So this one says the graph of the right on the right shows the remaining life expectancy, E, in years for females of age X. Find the average rate of change between the ages of 50 and 60. Describe what the average rate of change means in this situation. So X, it says, shows remaining life expectancy. So this is E or Y. That's your expectancy. And X stands for age. So our life expectancy given the age. So let's see, we have find the average rate between 50. So it's right here. Here are our 2 coordinates. These 2. So we have 50, 33.8. And then we have 60. And this is 25.2. So if we want to find the slope or average rate of change, we're going to find x1, y1, x2, y2. Use our formula. It's y2 minus y1. So y2 is 25.2 minus y1 over x2 minus x1. Subtract that. 8.6. 60 minus 50 is 10. Divide those. It's be negative 0.86. So that is our average rate of change between 50 and 60. So look how it goes down. Age and then life expectancy of years. So this is the life expectancy. Expectancy decreases each year between 50 and 60 years of age by 0.86 years. So it is a decrease, so it's a negative. And we're looking at just between each year between 50 and 60 years of age, it's decreasing by 0.86. Okay, that is all for the notes for 2.4. See y'all later.